Hey tech warriors, today we're tackling a classic headache. Why is your Linux server so slow? Your apps lag, queries time out, but CPU and RAM look fine. What's the real culprit? Storage. Disk I/O bottlenecks can cripple even the best hardware, and they're often invisible at first glance. If your NVM feels like a floppy, you're in the right place. We'll cover my top 5 command line tools to hunt down and fix I/O issues. Practical, actionable, and fast. From quick checks to deep dives, these tools will help you spot bottlenecks and speed up your system, ready to make your server lightning fast. Here are 5 Linux tools every sysadmin should know. Let's get started. Alright, let's dive into some classic tools for diagnosing storage performance issues. First up, we have a true veteran, a command line staple that's been around for ages, IOstat. It's a tool that's simple, effective, and gives you a wealth of information about your system's I/O activity. IOstat is part of the systat package, so if you're on a Debian-based system like Ubuntu, you can easily install it with. If you haven't already, go ahead and install it. On other distributions, use your system's package manager to install the systat package. This package provides a suite of performance monitoring tools, and IOstat is one of its shining stars. IOstat provides you with a quick, high-level overview of your system's CPU utilization, and more importantly for our purposes, detailed disk I/O statistics. It breaks down the read and write speeds, the utilization of your disks, and other key metrics that can help you identify bottlenecks. It's a fantastic starting point for any storage performance investigation. For real-time monitoring of your disk I/O, you can run the command. The flag tells IOstat to display disk statistics, the flag provides extended statistics, and the specifies that the statistics should be updated every 2 seconds. This gives you a dynamic view of what's happening with your storage in real time. When analyzing the output, pay close attention to the AND columns. These represent the number of read and write requests per second, respectively. A consistently high number here indicates a lot of I/O activity. Also, keep an eye on AND. These columns show the read and write throughput in megabytes per second. This gives you a sense of the actual data transfer rate to and from your disks, and perhaps most importantly, the column. If the is consistently high, say above 90%, but the throughput and is relatively low, then you've likely found a bottleneck in your storage system. This means your disks are working hard, but not moving much data. This is often due to a large number of small random I/O operations. Instead of efficiently reading or writing large chunks of data, the disk is constantly jumping around to different locations, which significantly slows things down. The column provides the average time in milliseconds that I/O requests wait to be served. This is a crucial metric for understanding latency. A high value indicates that your storage system can't keep up with the demand. Requests are queuing up, waiting for their turn to be processed. For example, if you observe that your database disk is consistently at 98% utilization with a high time, then you can confidently say that storage is the primary bottleneck, not the CPU or the network. The database is being starved for I/O. Now, IOstat won't directly tell you specific processes generating all that I/O, causing the issue. It doesn't provide process-level accounting, but it pinpoints the specific storage device that's experiencing the high load. This narrows down your search considerably. If you want to focus on a specific device, say, you can use the command. This will only show you the statistics for that particular disk, making it easier to analyze its performance. You can also use to get CPU statistics. In the CPU stats, look for a high value. This indicates the percentage of time the CPU is waiting for I/O operations to complete, which is another strong sign of disk-related performance issues. You can also log the output of IOstat to a file for later analysis. This is incredibly useful for tracking performance over time, or for investigating intermittent issues. For example, you can run. This command will run IOstat with extended statistics every 2 seconds for a total of 300 iterations and redirect the output to a file named. This is particularly helpful when you're trying to capture performance data during specific incidents or periods of high load. You can then analyze the log file to identify patterns and pinpoint the root cause of the problem. In summary, IOstat is a lightweight, fast, and readily available tool that gives you the essential metrics you need to start your storage performance investigation. It's a fantastic first step in understanding what's happening with your disks. So, if you want a quick and easy answer to the question, is my storage the problem? IOstat is the place to start. It's a classic for a reason. Next, let's dive into another powerful tool in your system administrator's arsenal, SAR, the System Activity Reporter. It's a utility that provides invaluable insights into your system's performance over time, while IOStat is fantastic for real-time observation, giving you a snapshot of what's happening right now. SR is your system's time machine, allowing you to travel back and examine performance data from the past. It's like having a DVR for your server's metrics. It works by recording performance data in the background, constantly and consistently. This background process is lightweight, ensuring it doesn't significantly impact system performance while diligently collecting data. It logs a comprehensive range of system metrics, including CPU utilization, memory usage, network traffic, and disk I/O statistics. This detailed information provides a holistic view of your system's behavior. By default, SAR typically records these metrics every 10 minutes, providing a granular timeline of system activity. This interval can be adjusted to suit your specific monitoring needs. The collected data is then stored in dedicated log files, usually located in /var/log/sa. Alternatively, you might find the data stored in /var/log/systat, depending on your system's configuration. These directories contain the historical performance data that SAR has collected. To view today's disk statistics, simply use the command sard. This will display the disk I/O information for the current day. Need to investigate a past incident or performance issue? No problem. Use the command srdf/var/log/sa/sa15 to access the disk statistics from the 15th of the month. This allows you to pinpoint the exact day you're interested in. This command retrieves the data from the SA15 file, giving you a snapshot of your system's disk performance on the 15th. Want to narrow it down even further to a specific time frame? Use sard or f/var/log/sa/sa15 as 145000, either 15th of October 00, to specify a start time of 14 hours, 50 minutes, and 0 seconds, and an end time of 15 hours, 10 minutes, and 0 seconds. This provides a focused view of system activity during that period. When analyzing the data, look for spikes in metrics like TPS, transactions per second, RD_SC/S, sectors read per second, and WR_SE/S, sectors written per second. These spikes can indicate periods of high disk activity. Also, pay attention to higher wait times during slowdowns, as they can point to disk I/O bottlenecks. Higher wait times suggest that processes are waiting longer than usual for disk operations to complete. For easier-to-read device names, use the sar-dp command. This option presents device names in a more human-readable format, making it easier to identify the specific disks being monitored. SAR can also perform live monitoring, providing a continuous stream of performance data. Execute srd25 to display disk statistics every 2 seconds, repeated 5 times. This is useful for observing short-term performance fluctuations. But what's the real power of SAR? The true strength of SAR lies in its ability to correlate disk, CPU, and memory statistics. By examining these metrics from the same time window, you gain a comprehensive understanding of how different system components interact. This allows you to see the full picture and identify the root cause of performance bottlenecks. You can also adjust data collection intervals to fine-tune SAR's monitoring behavior. These settings can be modified in the /etc/cron.d/systat file, which controls how frequently SAR collects data. Similarly, you can configure data retention policies in the /etc/systat/systat file, determining how long SAR keeps historical data. Need to analyze long-term performance trends? Simply increase the history value in the /etc/systat/systat file to extend the data retention period. In short, SAR is your go-to tool for historical analysis, providing a wealth of information about your system's past performance. It's invaluable for identifying patterns you'd otherwise miss, helping you proactively address potential performance issues and optimize your system's efficiency. So, you've identified that a particular disk is performing slowly, but the big question remains: which specific process is the culprit behind this bottleneck? It's like finding a leak in your plumbing. You know there's a problem, but pinpointing the exact source is crucial for effective resolution. Enter IOTOP. This unassuming command line tool is your key to unlocking the mystery of disk I/O performance. IOTOP is like TOP, the familiar process monitor, but specifically tailored for disk I/O. While TOP gives you a broad overview of CPU and memory usage, IOTOP dives deep into the world of disk activity, providing a granular view of which processes are reading from and writing to your disks. First, you'll need to install it, as it's not always included by default. Once installed, run it with sudo iotop. The sudo is necessary because iotop needs elevated privileges to monitor the I/O activity of all processes on the system. It shows real-time disk read-write bandwidth per process, giving you an immediate snapshot of which processes are actively using the disk. You'll see a list of processes, along with columns indicating how much data each process is reading from and writing to the disk every second. Plus, I/O wait percentage. This crucial metric tells you the percentage of time a process is spending waiting for I/O operations to complete. A high I/O wait percentage indicates that a process is being significantly slowed down by disk I/O. If your database is at the top with huge disk writes constantly churning away, you've likely found your culprit. It might indicate a need for query optimization, index tuning, or even hardware upgrades. Use the O key or O flag to show only processes currently doing I/O. This filters out the noise and focuses your attention on the processes that are actively contributing to disk activity. Declutter your view, making it easier to identify the key processes of interest. A cleaner view translates to faster problem identification. Try a for accumulated mode to see total I/O over time, rather than just the current instantaneous rate. This is particularly useful for understanding the overall I/O footprint of a process. Great for catching short bursts of I/O activity that might be missed in the default view. These bursts can be indicative of specific tasks or operations that are causing temporary performance bottlenecks. Sort by I/O GAS to spot processes spending the most time waiting on disk. This is a powerful way to identify processes that are being severely impacted by slow disk I/O. Batch mode, B, lets you script or log output for later review. This is invaluable for long-term monitoring and analysis, allowing you to track I/O patterns over time and identify trends. Combine with iostat. If %util spikes, indicating high disk utilization, trigger iotop to capture the top I/O offenders automatically. This creates a powerful feedback loop, allowing you to proactively identify and address I/O bottlenecks before they impact performance. iotop has minimal overhead and is invaluable for pinpointing the exact process causing trouble, without significantly impacting system performance itself. It's a lightweight tool that provides a wealth of information. Recap iostat or SAR tells you where the problem is, highlighting the specific disk or storage device experiencing high utilization or latency. iotop tells you who's responsible, identifying the process or processes that are generating the excessive I/O load. Together, they form a powerful diagnostic duo. Need a big picture view? Meet Destat, the all-in-one dashboard. Destat combines stats from iostat, vmstat, netstat, and more into a single, real-time, color-coded display. Run Destat for a default overview. CPU, disk, network, and system stats side by side. For detailed disk info, dstat, D, disk util, disk TPs. Color coding highlights trouble. Red means your disk is maxed out. Use top I/O to see the top I/O process right in your dashboard. Not as detailed as iotop, but perfect for quick checks. Export data easily. Destat. Disk util. Output /tmp/disk_report.csv 560 for CSV reports. Great for graphing trends or justifying hardware upgrades. Destat is modular. Add plugins for custom metrics or see a full list with Destat list. For a full system view, Destat CDLMMC. If you want to see how CPU, disk, and network interact in real time, Destat is your tool. Summary: Destat is the ultimate live dashboard for troubleshooting and correlation. Now for the final boss, ATOP. If top is standard and iotop is for I/O, ATOP is top on steroids, with historical per process detail. Run ATOP for a dense, all-in-one system summary. Press D to sort processes by disk activity. See RDDSK and WRDESK columns for per process I/O. The killer feature ATOP can run as a service, logging detailed snapshots every 10 minutes. After an incident, replay logs with ATOP r/var/log/ATOP_YYMMDD and step through time. Watch memory, CPU, and disk usage evolve and pinpoint the exact process that caused trouble. Color coding highlights critical resource use. Red means a process is maxing out disk writes. Filter by user, U, or aggregate threads. P for deeper analysis. Configure logging intervals in /etc/default/ATOP for more granular data. ATOP is your forensic toolkit for post-mortem analysis. When you need answers after a crash, this is the tool. That's 5 powerful tools for your Linux I/O arsenal. Start with iostat for a quick check. Use SAR for history. IOTop to find the culprit, dstat for a live dashboard, and a top for deep forensics. No more guessing, use the right tool for the job. Master these and you'll solve I/O bottlenecks fast. Your servers will be faster, your apps more responsive, and your nights more peaceful. Like, subscribe, and check the description for install commands and links. Drop your favorite tool in the comments. Until next time, stay fast, stay secure.